Good morning to everyone. In the previous class, we were discussing about the manhole. Of course, this manhole is used for the inspection purpose as well as the repair of pipelines. Suppose if any blockage is going to happen in between the sewer lines, so then it has to be rectified with the manholes only. So then this is a typical type of manholes. We already discussed that the shallow manholes and deep manholes. This is one typical type of deep manhole where the depth is higher than the width. So then in this you can see that these are some of the typical guidelines of the manholes as per the IS standard 1742 1960. Suppose if the dia of the sewer is up to 0.3 meters, then the recommended spacing on a straight reaches, that is 40 meters. Means straight reaches means what you can say, suppose this is the pipeline. So then where exactly you have to provide the manholes. So then if the dia is 0.3 meters, the sewer dia, if it is 0.3 meters, then the distance between these two positions, it should be 45 meters. So if the dia is up to 0.6 meters, then you can go with the 75 meters. So then dia if it is greater than 3, so you can have to go ahead with the 300 meters. So then here you can draw one major conclusions. What is that? If the dia is go on increasing, this is very important. If dia is go on increasing, even your spacing also go on increasing. Whatever the spacing between the sewers, it is also go on increasing. So that is one major conclusion we have to draw in this table. So then if you see that I already discussed the classification of manholes. So based on the depth, the manholes are classified as shallow manholes, then normal manholes, and the deep manholes. So the shallow manholes are ones which are about, if I say it is a shallow manhole, it is 0.75 to 0.9 meter depth. So they are constructed at the start of the branch sewer. Normally it will be started with the start of the branch sewer. So these are also known as inspection chambers that we already know. The normal manholes are normally it is of 1.5 meter depth, and either they are constructed in a square or it has in a rectangle in cross sections. So then the section such as manholes is not changes with the depth. It is provided with a heavy cover top, that is with the steel top cover that we already discussed. We have to provide with a steel top cover. Then deep manholes that we already seen in the previous diagram, the deep manholes are those which are deeper than 1.5. So when you say it is a deep, so it is 1.5 meter depth and is greater than that. The size of such manhole is larger at the bottom. If you see that section, whatever I showed in the diagram, it is larger at the depth. Means if you see this section, it will be like, then when it is go on moving, you can see the things here. It will be very less. That is what is telling, which is reduced at the top to a manhole cover. So of course, when it is go on increasing to the top, so it is go on the size is go on reducing. The reduction in the size is achieved by the providing offset of the RCC. That is offset what I showed in the diagram, that is offset. This is nothing but offset. This is what the offset. The steps are also provided on vertical walls, that the steps I have showed on the manholes to enable the workers to go up to the bottom. So heavy manholes are covered with the top, which are suitable of the CI frames. So then what exactly the dimensions of this manholes are? So the below table, it will give minimum internal dimensions. We are talking about the internal dimensions of the manhole chambers. So then the first one, that is normal depth 0.8 meters. The minimum size, of course, these are all based on the depth. Very important. These are based on depth. Why? Because whatever the size we are specifying, it is interlinked with the depth is interlinked with the size. So for 0.8 meter depth or lesser than that, normally we will provide with the 0.75 by points, that is of square. We already said that either square or the rectangle we will provide. So if it is 0.8 meter and 2.1 meter, so then this is 1.2 meter and 0.9 meter depth. Then greater than 2.1 meter, a circular chambers with minimum dia of 1.4 meter. So normally here we'll go ahead with circular. Here it will start with the rectangular. So then with the minimum dimensions of 1.2 and 0.9 meters. So minimum wall thickness has to be provided of this much. So if it is 1.5 meter depth, so you have to go for 20 centimeter. So if it is greater than 1.5 meter depth, normally for the shallow, what we are talking about, you go ahead with the 20. If it is a depth one, 30 thickness has to be increased, because when the depth is go on increasing, the depth is go on increasing, the depth is go on increasing, the thickness has to be increased, because the load will acts on the walls, inner walls of the manholes. If you want to reduce that, so then you have to go ahead with the higher thickness. So then, of course, this is a that is a deep manhole, and the one more is a drop manhole. One more type of manhole, that is called as the drop manhole. So it is a measure of connecting high level branch sewer to a low level main sewer. So they are connected through a vertical pipes. The installation of drop manholes becomes necessary when there is a difference in the levels of more than 60 centimeter between the branch sewer and the main sewer, so which can be avoided by increasing the sewer gradient. So very important this one. So drop manhole, of course, it is wherever the high level branch sewers are there, at the higher gradients will be there, that time we have to provide this drop manhole, and which are connected through a vertical pipe. The installation of the drop manhole becomes necessary when there is a difference in the levels more than 60 centimeters. Of course, wherever the difference between the two successive manholes, if it is, or the elevations, if it is more than 60 centimeters, there the drop manhole is provided. Means to if the gradient is more, normally what will happen is that uh, we assume that the sewers are with the gravity flow, then we have to provide with 1 is to 1000 or 1 is to 2000. If the gradients are too high, in some of the situations happens that you may not able to excavate more trenches than some of the recommended guidelines. In that cases, it is better to go ahead with some of the drop manholes. Drop manholes means a little bit more depth than the normal manholes. So this is what the drop manhole. So if you can see here, here your branch sewer is there, and here is main sewer is there. If that is the case, you can see the elevation here. Here it is the branch sewer, and here it is going like this. Whatever the sewers, it will go like this. But it has to come into this one. Whatever the branch sewer is, it has to be connected to the main sewers. If that is the case, then what we have to provide is that with the help of the vertical pipe, we have to provide, we have to give the connection to the branch sewer. Then this whatever the drop manhole what we are talking about, drop means little bit depth is little bit higher than whatever your the deep manhole. So if you construct the manhole with the lower depth, so then we can say it is a little bit a dropper manhole. You can see the gradient here for the branch sewer and the main sewer. This much height is there. If this is the case, if this is happening means you have to provide with the drop manholes. Of course, this is a manhole cover. This is a ground level. These are the steps what you are seeing. Then this is a working chamber. Then this is a plug for what we can call so that the water, the sewer should not fall directly onto the main sewer. If it is flowing in this direction, suppose if you don't provide any plug here, then automatically it will fall here and it will corrode the some of the steps which are there in the manhole. Then some of the components, these are the exit shaft, working chamber, bottom inward, side walls, steps or ladder, and the top cover. So then this is the gutter inlets. The gutter inlets are composed of curb or a gutter inlet acting to a single unit. Normally, gutter inlets are placed right in front of the curb. Curb you already know in the highway engineering. If you see the curves, that is, we can take it as a side portion of your road. There it will be provided so that whatever the water will be there, it has directly reaches to the stormwater drains. Suppose assume that this is a footpath, it is a road, then made up of a concrete box. Then some inlets has to be provided. This is moving towards the stormwater drains. So in that only they will make some provisions so that it should enter to the stormwater drains. We have seen that we have two types. One is sewer and one more is stormwater pipes. This has to be connected to the stormwater drains, not to the sewers. Very important. Then gutter inlets has to be provided with here also you can see in the first one the curb inlet. In the second one you can see the road surface is like this. Here the road surface is like this, and here you have drains are there, but here you have drains are there. Means the water should go like this. Here the water should move like this. So this is what the difference between your curb inlet and the gutter inlet. Normally you have seen in many of the highways, sometimes at the side of the curb they will provide these all drains. This normally we can call it as drains. This also gratings or the strains or the strains. This is of course the inlet to the drains. So these are the gutter inlets provided so that the drain water should enter into the stormwater drainages. Okay, then next catch basins we'll discuss in the next class. Thank you.